Welcome to another video, ladies and gentlemen. I have a question under Newton's laws, which is saying in the system of figure 3.18 and the mass of the pulley are both negligible. So they're saying the mass and the friction of the pulley, this one here, are negligible. So we don't have to worry about the mass and the friction around the pulley because they're negligible. Find the acceleration of mass 2. If mass 1 is 300 grams, mass 2 is 500 grams, and the force, this one here pulling this one, is 1.50 newtons. Now what we need to know is that acceleration, it will be common in most cases. Okay, it will be what? It will be common. So what we need to know here? Well, look at the pulley type of which type of a pulley system is this? This is a single movable pulley, all right? And for a single movable pulley, this tension is the same as the tension here. So it's the same one here. And the sum of forces in according to Newton's laws of motion should be equal to what? 0, right? That is the resultant force. So this force and this force should be equal to this one. So we are saying Ft1 plus another Ft1 should be equal to Ft2. I'm just talking about tensions before this one. I'm not first interested in this one. I'm just talking about these three, which would be 2 Ft1 is equal to Ft2. So Ft1 is what? Half of Ft2. Take note of this. So this is a single movable pulley, so we are going to apply that idea. Need to have it. Another one is that look at the pulley properly. You discover that when the pulley, this pulley moves a distance d, for example, all right, you discover that mass 1, because the mass 1 is more like half of there. Okay, it's almost the same as this one. I'm sure you can see, right? So you discover that it's the same one here again, like that. So you discover that when mass 1 when mass 2 moves a single distance, or let me say when the pulley moves distance d, or I can call it anything, the m1, it moves 2d. Why am I saying it moves 2d? Because for every single movement of the pulley, this small mass, it will move twice the distance. I'm sure you can see. It will move twice what? Twice the distance. If that's the case, that means M1, it also moves twice the what? The acceleration. Okay? Twice the what? The acceleration as M2. Because of this, what we have established there. So now we are going to break this into components. Now that we understand where we are basing our calculation from, we can now calculate what? The components. So I'm going first to find everything on M1, then we go to M2. So in terms of acceleration, we are saying the acceleration on M1 is just 2a, because it's twice the acceleration of M2. Okay, the same way is twice the distance moved by M2. Now we know that, so let's look at the first part. We are going to take note that the movement is along the x-axis, so all our calculations are going to be based in the x-axis. So we know that the sum of forces, according to Newton's second of motion, it's mass times what? Acceleration, but acceleration is what? In the x-axis. So let's talk about the first mass, this mass here. Okay, the first mass is just the tension is here. Okay, that's the tension that we are focusing on. The tension is F, okay, T1 is equal to mass 1, okay, multiplied by, what did we say is the acceleration for this one is 2a. So that is 2a, because it's moving the same way it's moving the distance twice, even the acceleration will be twice. Then that is the first component. The second component that we're going to target now is for M2. All right. So for M2, remember that for M2 there are two forces. Before I even go anywhere, the only force acting on this block here, the M1, is this force, not this one. This one is acting on this one, is also being acted upon by that one. So in case you are wondering why I did not include FT2 here, it's the only force. That force is only acting on this one, but it's not acting on the M1. I hope that is clear. All right, so for M2, we have this friction, which is pulling the other side, and this force, which is moving the other side. So it will be F minus F2T should be equal to the mass. Acceleration, it will just be A. Why am I saying acceleration will just be A? It's because we are saying the smaller mass is moving twice the acceleration of this one. So if the acceleration of this one is A, this one is going to move it twice. So if this one moves a distance, what? D, but this one will move a distance of what? 2D. That's what I'm trying to say. Even the acceleration to be the same. So now that since we've established these equations, well, we can do that. But remember what we said here. This is very important. So now, I think the question is even done. Okay, so we can just now do the replacements and, well, we'll be done. So know that FT1 is this here. FT1 is this one. So where there is the F21, we are going to put half FT2 is equal to M1 then 2A. Okay? Then we can make FT2 the subject of the formula from here by crossing multiply. So this 2 is going to multiply that to there, so that we can have FT2 is just equal to what? 4 M1 what? A. Keeping in mind we've got F minus FT2 here being equal to M2A. So now, what do we need? We can substitute, since FT2 is equal to this, so here we're going to say F minus, open brackets, 4 M1A is equal to M2A. M1 and M2, we know them. All right, we know them. Even F has been given to be what? 1.5. So we can now start substituting now. Okay, all right, so we have one. Let's do this. Remember that we are looking for M, so we have force is equal to M2A. So on the other side becomes plus 4M1A. We can factorize what? A, so that we can remain with M2 plus what? 4M1 and acceleration out. So now you divide by M2 here plus 4M1 both sides, M2 plus 4M1. So we get to eliminate that and that our acceleration, which we are looking for now, is F. Remember that this acceleration we established here, the acceleration of this one is half this one, but the acceleration of this one is twice this one. So what are we going to put here? M2 plus 4M1. Well, let us now replace 1.50 over, well, what you need to do is that mass should be in kg. So we multiply this one by 4, which will give us what? 1200 over 1000, which will give us 1.2 kg. This one over 1000 gives us 0.5 kg. Now we come here, so we've got 1.2 plus 0.5. Get a calculator. Alright, so let us punch. So 1.2 plus 0.5. Okay. Alright, 1.5 by 1.7. It is 0.88, something like that. So I'll just leave it to 0.88 meters per second is correct. That is the acceleration. I hope you enjoyed the video and I hope that it made sense. Please don't forget to subscribe to my YouTube channel and follow me for more.